Section 4.2, we're going to continue on. Remember last week we were doing solving systems by graphing. Now the problem that we have is, and the ones that you guys had all came out nicely, like on nice corners of the graph, or at least they were supposed to, so that you didn't have to guess a whole lot, like it was going to come out to be like exactly 5, 2, or exactly -3, 12, or I mean 12 is too big, but anyway. The issue that we have is sometimes they don't come out to be nice, even answers. Sometimes they come out to be decimals or fractions, and that's really hard to see on a graph.
Yes.
Right? So we have some algebraic methods, and that's what we're going to be doing tonight. We're going to be studying the algebraic methods of how we solve systems. And the first one is substitution. So before I go on, I'm assuming you guys have probably heard this word substitution somewhere in your lives. What does it mean to substitute something?
You want one thing, but you get another.
You replace it, right? It gets replaced. Like, you know, sometimes you go to a store and something is on sale, but they don't have anymore, so they substitute something else in place of it, right? Now, in math, we do substitution, and that's exactly what it means. We're going to replace one thing with something else. The thing in math, though, is the two things that we're substituting have to be exactly equal, okay? Like if I give you $1 and you give me 4 quarters, that's okay because that's equal. If I give you a $5 bill and you give me 5 ones, that's okay because that's exactly equal. And in math, that's what it has to. It has to be exactly equal so that we can make that substitution without changing everything else. Okay? Does that make sense? Because sometimes you go to the store and you want to get one thing and you get something else, and that's not a great substitution for you, right? In math, it has to be exactly equal.
Are we distracted today?
I just like to not be distracted, so I close the store.
All
right. Substitution. So remember, and I mentioned this already, solving a system by graphing has several limitations, so we don't like to use that if we don't have to. And so we're going to start with a fairly easy one. We are going to solve this system by substitution.
Put 5.
Now notice, we know right away what x is, right?
Yep.
They just tell us x is 5. So when we go to this second equation, we can take this x and we can replace it with what? 5. So we're going to have y equals 2 times 5 minus 3, and that means 10 minus 3, and that means y is 7. And again, this was a really easy example, but that means our answer is 5, comma 7. Okay, does that make sense? And if we put those values in, it should make both equations true, just like with the graphing ones. Once we found our answer, we should be able to check, and it should make both equations true.
5 equals 5.
Okay? Yeah, 5 equals 5, so that's good. And then 7 equals 2 times 5 minus 3, that is also true. So that is our answer for that one. Now, again, that was a really easy one. We just gave you one of the answers right away. Now, I will mention on your My Open Math site, make sure if they've got 2 boxes, one for the x and one for the y, make sure you only put one answer in each. Because I know I saw a couple people that had accidentally put both answers in one box and then one of the answers, and so they got mixed up on how they want the answer. So just be aware of that. But that's our first example.
Okay.
Now, more of the examples are going to look, or the problems will look something like this when we're going to do substitution.
Okay.
So if we look at this, do you notice right away we know exactly what y equals? They didn't tell us a specific number, but we know that y is equal to 3x minus 7. Right?
Mm-hmm.
So what we do,
2.
we know that this is y. So if we know that, we're going to go to this other equation. We always go to the other equation. And we're going to write down 2x minus 3 times y equals 7. But we're going to replace the y. We're going to substitute. What do we put in place of the y? Because this was a y.
3x minus 7.
Does that make sense? We can replace the y with 3x minus 7 because they're equal?
Yes.
So we put in a 3x minus 7 here. Now, why would we want to do that? Here's the reason. Now we have an equation that's only x's. If you have an equation with x's and y's, you can't really solve it very well. But if you have just x's, we learned back in chapter 1, and hopefully remember some of it, how to solve for one variable. And so that's what we'll do. So I'm going to erase this little y up here. just so it doesn't look confusing. So if this is our equation now, what would we do first to begin solving that? Yes, the little rainbow distribution. We're going to distribute. So I'm going to just write down the 2x. This -3 distributes to the 3x, and what do we get there?
-9.
Minus 9x. You just multiply the numbers together. Then the -3 distributes to the -7, and what do we get there?
21.
Plus 21, positive 21. And that ends our distribution, and then we have equals 7. Okay. Then we want to go ahead and add our like terms. So we can combine these two. And what do we get when we add, or we combine the 2x minus the 9x?
-7.
-7
Sorry.
x, yep, -7x plus 21 equals 7.
That's 21.
And then again, what do we want to get rid of next? We want to get rid of the 21 because it's the outer layer, right? It's further away from the x. So how they're adding it, we want to subtract 21. So -7x is what we have left here, and then here we have -14. And then our last step, divide by the -7. So x equals 2. So now last time they just told us x was 5. We had to do some work this time, but we know x equals 2. So in our answer, we're going to have 2 comma something, right? Now here's the nice thing. We're going to take that 2 and substitute again. They call it back substituting, and we're going to put it right back in here. Does that make sense? And so now we know y equals 3 times x minus 7, but we figured out that x was 2. So 3 times 2 is 6 minus 7, and that means y is -1. So 2 comma -1 should be our answer. Now remember what we're supposed to be able to do. We're supposed to be able to plug these numbers in and check. So I'm going to switch colors here. This would be 2 times 2 is 4, minus 3 times -1 is -3. And remember that when you subtract a negative, it's the same as adding.
So 7.
So 4 plus 3 equals 7. That's good. That's what it's supposed to be. And this one is what we use, so we probably don't have to check this one, but if we want to, -1 is supposed to equal 3 times 2 minus 7, and that is also true. 6 minus 7 is -1.
I love those.
You can always,
I like those two.
you always can check your answer. This is so easy?
Mhm.
Good. Hopefully the math, the algebra that we've learned before about solving equations comes back to us and we can do these fairly easily. Any questions on that one before we go on? All right.
For you.
Now,
We're home and then we're like, what? What did I want?
No, at home it's okay.
okay. So notice what's different about this one. They don't have the y by itself. They don't have the x by itself. But here's the deal. We want one of those two to be by itself. So here's what I always tell my students. So let's make this as easy as possible. Look up here. Which variable do you think is going to be the easiest one to get by itself?
X.
The x. The x in which equation?
Second one.
The second one. Does everybody see why? Because it's just an x sitting there, and all we have to do is get rid of the y, and then the x is by itself. Does that make sense? If you see something that looks like this with just an x, that's probably the one you want to do. Does that make sense? Everybody's really tired on this Tuesday. So.
Because you're just gonna do one thing and you gotta get
Yeah,
x
one step and we can have the x by itself. How do we get this x by itself?
plus 5y.
Add 5y. So now we know x equals
5y plus 6.
5y plus 6 or 6 plus 5y. It doesn't make any difference because it's adding. Okay. So now, again, we know that x equals this value. These are the same. These are equal. So we go back up to the other equation. 3 times x plus 2y equals 1.
Mhm.
And what are we going to put in place of the x? 5y plus 6. And again, do we realize why that's a good thing? Now our equation only has y's. We don't have two variables, we just have one. Okay, so now what do we do next? We're going to distribute. So 3 times 5y gives us 15y. 3 times 6 gives us 18 plus 2y equals 1. Again, once you do that distribution, I would suggest go ahead and combine the like terms. We've got a 15y and we've got a 2y, and together they give us 17y plus 18 equals 1. So now that we just have a y in one spot, how do we continue trying to isolate it, get it by itself? Subtract the 18. Cancel. So now we just have 17y equals negative 17. How do we finish that up? Divide by 17. And we get that y equals negative 1. Now here's where you want to be careful. When you write your answer now, it's y, so it goes second. Right? Make sure you keep them in order. X goes first, y goes second. Does that make sense? So you're not always solving for x first or always solving for y first. It's just whichever one you get. So in this case, it's negative 1. No, y is negative 1. Then what do we have to do with that once we know one of the answers? Go plug it back into the other one right here. So x equals 5 times y plus 6. And what did we just figure out that y equals?
Negative 1.
Negative 1. So 5 times negative 1 is negative 5 plus 6. And that means x equals 1. So our answer would be 1 comma negative 1. Now, if you think about the graph, do you kind of see what's happening here? These two lines are intersecting at that point, 1 comma negative 1. If you think about what you did last week in the homework. So that's the idea. These two lines are going to intersect in a spot, and this is algebraically how we could find the spot where they intersect.
Oh,
What?
Okay?
did you say that at the beginning of the class?
Today? I don't think so.
Oh, okay.
So last week we were drawing the lines to find out where they intersect. Here we're doing the math of the algebra to find out where they intersect. So we're finding the same answer that we would find graphing, but we're doing it with algebra instead. I'm not going to show you, but we could graph these lines. You could graph these both, and
If
you
you
would get
grab those lines,
they
it
would-
will be the intersect.
they would intersect right there. Remember where they intersect? That's your solution, part of both lines. Any questions on that one?
And in order to graph them, we will have to put them in a slope.
That would probably be the easiest. You don't. There are other ways, but that's the easiest way to do it. Okay, are we okay with that one? Nobody's saying no. So
If we don't substitute, and can we do that? Like addition or subtraction, can we do like that?
we're going to do that. That's the next one.
Okay.
You're talking about, they call it addition, they call it elimination. That'll be what we do in 4-3.
Gosh, Sally.
She's just trying to jump ahead.
No,
Okay.
I'm
No, you're fine. You're fine.
I'm
So
fine. I
here's the substitution process. First of all, find a lone variable. So get one of the variables by itself.
So if it is like in the test, if they say substitute, you have to substitute, right?
On the test, I did not put any strictly substitute. I have some that are you have to graph, but then the other ones are solve them algebraically. So
whatever you
substitution
want.
or elimination, either way.
Okay.
So substitution, find a variable, get one variable by itself. So find the lone variable. Solve for the lone variable. Then you substitute, they call it substitute into the untouched equation, the one that we haven't used yet. And then we solve, and then we plug it in, plug into the one variable equation and evaluate. So this is just the steps that we've already been doing. So nothing new here. It's just written out in words, except for this should say into, at least in my opinion, into the one variable equation. Okay, so if you want to fix that so it makes sense, I like my sentences to make sense as much as possible. All right, so that's our substitution process. All right, so let's go ahead and solve this one, because like we saw before, sometimes some unique things can happen. So let's take a look at this one. Which variable, and we've got a lot of options here, so I just need somebody to decide, which variable would you like to get by itself?
X.
The x, and in which equation?
Second one.
Second one, so you're going for this one?
Mm-hmm.
Now, could we choose something else this time?
Mm-hmm.
Yeah, we could choose this x and it would be fine. We could choose this y and it would be fine. This one you could still do, but it would be the hardest one out of the four. So, but we can go with this. How do we get this x by itself?
Plus y.
Add y. And that gives us x equals y minus 1. Okay. Then remember, we go back to that other equation that we haven't used yet, and we're going to put in x plus y equals 5. And what are we going to put in place of that x?
Y minus 1.
Y minus 1, because that's what we know that x equals. We do the substitution, right? You're going to replace. So looking at this, now I put in the parentheses here, but are these parentheses, do we have anything to distribute this time?
No.
So do we need the parentheses?
No.
No. So I'm just going to rewrite it with no parentheses. You don't even have to do that. You can just ignore them. But now we want to add the two y's together, and what do we get?
2y.
2y minus 1 equals 5. Then what should we do? Add 1. You guys are all over this tonight. That's good. 6 and divide by 2. So we find out that y equals 3.
Mm-hmm.
Okay, so again, when we write our answer, make sure you put it in the y spot. The y value is 3. Now what do we have to do next? Go back to here
Up to 2.
and substitute it back in. So x equals, we know that y is 3 minus 1, so x is
2.
That's an easy one, isn't it? And again, you can check your answers. 2 plus 3 equals 5, yes. 2 minus 3 equals negative 1, yes. They both work out. Okay.
Are you gonna be able to use notes?
What's that?
Are you gonna be able to use notes?
Oh, probably not.
Okay.
But I'm only doing 3 sections this time. Last time I can understand it was like, what, 6 or 7 sections? So are we okay with this?
Yeah.
All right. Let's take a look at this one. So once again, let's take a look here. Which variable do we think will be the easiest one to get by
What is-
itself?
What is that and why?
2 comma 3 was the answer. The y, which y?
The top one?
The y on the top, right? So the y on the top, we're going to get this by itself. And how are we going to do that?
Subtract 4.
Subtract 4. So now we know y equals 3x minus 4. We've practiced that, right? That's kind of slope-intercept form. It's really this. We're doing the same math, right? Get one of the variables by itself. So then we go to the other equation, and we replace the y. So we've got 2 times y minus 6x equals negative 8. What are we going to replace or substitute in for the y? Did you have a question?
3x minus.
On the first one,
Yeah.
it's 3x, so the plus is switch it to minus 4?
Because we're trying to cancel out this 4. In order to cancel it, that plus 4, we need to subtract 4. Does that make sense?
Mhm.
Yep, because we're trying to cancel it out. So now what are we going to put in place of the y?
3x minus 4.
Yeah, the 3x minus 4, because that's what y equals, right?
Mm-hmm.
3x minus 4. Now we only have x's. Do we need to distribute this time?
Yes.
Yep. So 2 times this is going to be 6x. 2 times that is going to be minus 8. Minus 6x equals negative 8.
Mhm.
All right, so combine like terms. What happens here?
Eliminate.
They cancel out. 6x minus 6x is 0, right?
Mm-hmm.
So all we have left is -8 equals -8. And you're like, well, duh. Of course, -8 equals -8. But here's the important thing. This is a true statement, right?
Mm-hmm.
This is a true statement. There's no way to make it false. -8 equals -8.
Mm-hmm.
There's no variables left. It's either true or it's false. Does that make sense?
Mm-hmm.
So if all the variables if all the variables cancel out, that's one of our special cases. It's either always true or it's always false. In this case, always true. So what that means is these two lines are actually the same line. It's always true. They're always together. They're always intersecting. And so we have infinitely many solutions. And we've heard that phrase before, right?
Mm-hmm.
In other cases. So there are infinitely many solutions. Now, when we write our answer for that, since they're actually the same line, and we've already got it done here, usually what we do is we just take one of the equations and we solve it for y or whatever. And we put it in slope-intercept form. And so we just describe the solutions. This is our description of the solutions. Anything on that line is a solution to both equations. Okay. Sometimes you'll see it this way. You can choose any x value, and once you choose the x value, the y value is going to be 3x minus 4. Because that's x comma y. And you see how y is this? And what that means is you've got infinitely many solutions. So if I choose x equal to 0, I would have 0,
Minus 1.
comma, -4 when you plug that in, 0 minus 4. If I chose x equals 1, I'd have 3 times 1 minus 4 is -1. If I chose x equals 2, that would be 3 times 2 is 6, and minus 2 is 2.
Why you pick that equation?
Why did I pick that equation?
There's another 2 equations. Why you pick that one?
These two?
Mhm.
Because this is the one that's already solved for our variable, so it makes it the easiest to work with. Okay? And I'm
But
going to have
if
to...
you want to pick the other one, it's okay, right?
You could, but you want to solve it anyway, and since they're the same, it's still going to turn into this. They both will turn into this.
Mm-hmm.
Okay? It'll just take some more steps because they're the same equation.
So, for the answer, you would like for us to do like the x?
I'm gonna double check. I want to check the homework. I can't remember off the top of my head how they wrote the answer for these. So I'm gonna double check. They may just write down infinitely many solutions and not worry about how you write the answer. So I need to double check that.
Okay.
And really what I'm the most interested in for you guys this semester is that you get infinitely many solutions. Now the other option is, what happens if you get to this point right here and you have a false statement? What do you think that would mean?
No solution.
No solution. There's no way to make, like if this said -8 equals 12, there's no way to make that true because the variables are all gone, and that would be a false statement, and then that would be a no solution. That means the lines are parallel, right? If you think about what's going on with the graph, that would mean the lines are parallel.
So they're never.
They never touch. Okay? And chances are that's what this one is, so let's go ahead and do it. Is this the last example?
No, we got to.
We got 2 more?
2 more.
All right. So looking at this one, which variable do you think would be the easiest one to get by itself?
Y.
Probably this y right down here. So how would we get it by itself?
Yes. That's 2x.
To get this y by itself, we want to cancel this out, so we're going to add 2x. So y equals 2x plus 5.
Mm-hmm.
Okay. Then we're going to go to that other equation, 6x minus 3 times y equals -9. And what are we going to replace the y with?
2x plus 5.
2x plus 5. Okay. And then what have we been doing every time after we substitute?
Distribute.
Distribute if we need to, and we do need to. So 6x, distribute the -3 to the 2x, we're going to get -6x. -3 to the 5 gives us -15, and -9. And so notice what happens this time when we combine the x's. They cancel out, right? So does anybody see a problem with this statement?
No solution.
Does -15 equal -9?
Mhm.
No, that means this is a false statement. All the variables are gone. It's a false statement, so that means there's no way to make it true. There is no solution to this one. And usually in the directions of the problem, they'll write down what you're supposed to write down if there's no solution. Sometimes it's DNE does not exist. Sometimes it's whatever, none. So you just have to look at the directions. They usually have it set up to tell you what you should write down. I'll just tell you on the test, I would like you to write no solution. So that's what I'm looking for. Okay, any questions on example 175? Isn't that impressive? We've done 175 examples.
No.
That's not impressive. It seems impressive to me.
That's on paper.
All right.
Not in our brain.
Oh, we're wasting a lot of paper. I don't have to print them off for you. You could write it down
No.
yourself.
No, she didn't say that.
Oh,
Why your listeners is so poor?
sorry.
Just
I was
kidding.
not really paying attention to you. So, okay, now this one's a little bit different because there's not just a letter that's all by itself, right?
Mhm.
But again, we can ask the question, which one do we think will be the easiest one to get by itself?
Why? It doesn't matter. It's like,
I think it does matter, and here's why. Let's think about what would happen. We would have to add or subtract first, right? And then we'd have to divide this time. If we tried to get this one by itself and we divided everything by 5, is that going to turn out nicely for us? We're going to have fractions, right?
mhm.
What about if we divided by 6? Would that turn out nicely?
No.
No, we'd have fractions again.
I see.
What about
Oh,
if we
I see.
divided by 2?
Yeah.
That would be okay, right? No fractions there. If we divided by 4, this wouldn't be a fraction, but this one would. So there's still many times an easiest one. So I would suggest going with this one. So if we're going to get that, well, just the x actually. If we're going to get the x by itself, there's 2 steps this time. What do we do first?
Subtract 4y.
Subtract 4y. So -2x equals, cancel that. I'm going to just leave it as 12 minus 4y in that order. Then what else would we do?
Divided by -2.
Divide by -2. That cancels that. We divide everything by -2. X equals, this is now a -6. This will be a plus 2y. So do we see it still worked out okay? And you might, just so it looks nicer, you might want to switch it around to 2y minus 6. If you want to. You don't have to, but you can.
So, okay, so this time you put 12 before -4y.
I did. I just like to put the positive one first, but then when we divided, then it switched anyway, so I ended up switching it at the end. So it doesn't matter which one goes first as long as the sign stays with the -4. Or like here, the sign is with the -6. So if we switch it, the sign has to stay with the negative has to stay with the 6. Just make sure your signs stay with the correct numbers. So now we have the x all by itself, right? We go back to this top one that we haven't used yet, and we're going to write 5 times x minus 6y equals -14. And what are we going to replace the x with? 2y minus 6. Okay, and then we have to do what?
Distribute.
Distribute. So this will be 10y minus 30, and then minus 6y equals -14. And just like we've been doing in the past, we want to combine. So this gives us 4y minus 30 equals -14.
Add 30.
Add 30, correct. So that cancels, and we have 4y equals 16. Divide by 4, and we get y equals 4. So again, in your ordered pair, the 4 is the second number because that's the y value. What do we have to do to figure out x?
Put it back up.
Take it and put it back in right over here. So x equals 2 times y minus 6, and we just figured out that y is equal to 4. So that means 8 minus 6, which is 2. So 2 goes in here. Again, if you want to check your answer, this would be 10 minus 24 equals negative 14. That's true. This one would say negative 4, 4 times 4. So plus 16 equals 12, and that is true. So we know that's the correct answer. I'll get out of your way here, sorry. Or you can scoot over if you want. You don't have to stay that far away from her. I think you'll be okay. Okay, now I'll just tell you, we can do this problem with substitution. I never would. In fact, most of these problems I would not have done with substitution because I have the other method that I actually like better, which is what we're going to learn next in section 4.3. Okay, but does substitution make sense?
Yes.
Okay, and how we do that, and it's all based on replacing, right? You take one thing, you replace it with something else that's equal to it. So that's substitution. Okay, and as I mentioned on the test, I'm not going to specify, other than graphing, when you have the graphs there, you're going to have to graph them. But when I say solve this system and I don't have a graph there, you can solve it with either substitution or this next method we're going to talk about, which is called elimination.